Are you running a lot of Apache Spark or Hadoop workloads on Google Cloud Dataproc? There are several ways to monitor Hadoop and Spark applications. In this video, we will see how to configure a persistent history server to monitor the Spark applications. I am Anu. I am a strategic cloud engineer at Google. Let's get started. In this video, you will learn what is persistent history server, how to set up a persistent history server, and some of the best practices of setting up a persistent history server. What is Dataproc? Dataproc is a fully managed cluster platform for running big data frameworks like Apache Hadoop, Apache Spark, and various big data open source tools and frameworks to process and analyze vast amounts of data. Let's take Spark workloads. How can you run your existing Spark workloads on Dataproc? With Dataproc, you can run your Spark workloads on Dataproc Serverless, long-running Dataproc on Google Compute Engine or Google Kubernetes Engine clusters, or Ephemeral Dataproc clusters. What is Dataproc Serverless? With Dataproc Serverless, you can run Spark batch workloads without having to provision, manage the cluster and the servers. With an ephemeral cluster, life of the cluster is tied to the Spark job. What do I mean by that? You create a cluster, configure it to run specific Spark jobs, and delete the cluster. You can use Dataproc workflow templates or Cloud Composer to orchestrate this. These clusters can be benchmarked, sized based upon the Spark jobs. These job-scoped ephemeral clusters are effective for batch processing. The challenge with ephemeral clusters and Dataproc Serverless for Spark is that you will lose the application logs when the cluster missions are deleted. Persistent History Server enables access to the completed Hadoop and Spark application logs for the jobs executed on ephemeral clusters or serverless Spark. Persistent History Server is stateless and it constructs the Spark UI of the applications by reading the application's event logs from the Google Cloud Storage bucket. Let us see how to configure a persistent history server. Step 1. You need to create the persistent history server Google Cloud Storage bucket in advance. Step 2. Configure the logging directory property when creating ephemeral clusters or serverless Spark batch jobs. This is the directory in the persistent history server GCS bucket to store the event logs. So far, we have a persistent history server Google Cloud Storage bucket created and configured the clusters to write the logs to that bucket. Step 3. Create a standalone cluster and configure it to read the event logs from the persistent history server GCS bucket. This standalone cluster constructs the Spark UI of the applications by reading the event logs from the Google Cloud Storage bucket. This is a persistent history server. Now it's demo time. We will see a demo of setting up a persistent history server. Let's navigate to the Google Cloud Shell. In the console, this Cloud Shell provides command line access. I have created a Google Cloud Storage bucket to store event logs from ephemeral clusters. That step is not included in the demo. This gcloud command creates a persistent history server. You will find the details of the code in the description of the video. Now the cluster creation is in progress. This command basically configures the cluster to access the Spark and MapReduce job history files and yarn aggregation logs from Google Cloud Storage bucket. Now the cluster is created. The public documentation has all the details on how to configure this. The link is in description section. I highly recommend you refer to that when setting up. If we check the configuration and click Show Properties, it shows MapReduce job history directory and Spark event log directory, done directory, intermediate directory, and event log directory. These directories are used by persistent history server to construct the MapReduce and Spark UI from the logs. Now you can access the Map History Server UI and Spark History Server UI by navigating to the Web Interfaces section. Now we will see how to configure Ephemeral cluster to write the logs to Google Cloud Storage bucket. This gcloud command creates an ephemeral cluster and configures it to write the logs to the same GCS bucket that the persistent history server is accessing. This cluster creation is in progress. Now the cluster is created. We can submit a sample Spark job to the ephemeral cluster. I am going to test with a Spark Scala job. In the main class, I am passing the main method of the Scala application. This is a Spark Pi program. It calculates the rough value for pi using an approximation method. I can pass the corresponding jar files. I am setting the argument to be 1000, which indicates the number of job tasks. Now I click Submit. This job is submitted to the ephemeral cluster. And this job writes the event logs to the persistent history server GCS bucket. To check the running application, you can access the Yarn UI by navigating to the web interface section of the Ephemeral Dataproc cluster. The status of the job is completed. So now we can navigate to the Spark history server of the ephemeral cluster. And this shows the Spark Pi application details. If we click on the app ID, it shows that there are 1000 tasks, which is the argument we passed. Next, we can navigate to the Spark UI of the history server instance. And this presents the application details and corresponding event logs of the jobs run on ephemeral cluster. If we click on the app ID, it shows the stage level, task level details. This is how you set up a persistent history server to monitor and analyze all the completed applications. Now we will see some of the best practices of setting up persistent history server. Best practice 1. To start with, a single persistent history server for a GCP project is optimal. If there are multiple applications running and if you want to isolate and monitor specific business applications, you can create 2 or more persistent history server GCS buckets, then create 2 or more persistent history servers pointing to the corresponding GCS buckets in a project. Best practice 2. In the event of a zonal or regional failure, you can quickly create a new persistent history server in another region pointing to the same persistent history server GCS bucket. Best practice 3. We recommend you benchmark with your existing Spark applications in the testing environment before promoting the persistent history server to production. In production, monitor the instance for memory and CPU utilization. In case of performance degradation in the Spark UI, you can recreate the persistent history server with increased machine size with higher memory. Best practice 4. By default, the Spark daemon memory is 3.8 GB. If many users are trying to access the Spark UI and dig into the job application details, or if there are long-running Spark jobs with many tasks like 50,000 or 100,000, the 3.8 GB heap size could be too small. This might impact the Spark UI performance. In such scenarios, try increasing the heap size to 8 GB or 16 GB. Best practice 5. Configure a 30-day lifecycle policy in Persistent History Server GCS bucket to periodically clean up the event logs. This will improve the performance of the Persistent History Server UI. In this video, we saw what Persistent History Server is, how to configure a Persistent History Server, and some of the best practices. Persistent History Server is important for troubleshooting issues and engaging Google Cloud technical support to troubleshoot and explore. You can also use the logs to optimize the performance. There are various other scenarios to consider when setting up a Persistent History Server. I am sure this video sets the foundation to get started. To stay on top of all the latest changes, periodically review Dataproc release notes. This helps you adopt new features and functionalities. If you are interested in exploring more about Dataproc or the History Server, please check out the description section in this video. Thank you for your time. Thank you for watching.